before we get started, I want you to write down exactly what our goals are for this video, for this lecture. And what our goals are going to be, first, I want you to be able to use the product and quotient rules to make solving problems with exponents simpler. That if we use these rules well, and we use them like they should make our life a whole lot easier. And the other thing I want you to do today is to understand how these rules make solving problems simpler. So not just what, this first goal is more of like the what type question. What are we going to be doing? How to solve the problem? And this second piece of this is I actually want you to understand how they make your life simpler. So not just what they do and what they are, but why. Why do they matter? Why do we learn exponent rules? And so before we really begin diving into what the product rule is, what the quotient rule is, we're going to start by just talking a little bit about exponents and why exponents are necessary, why they help us. And we're going to start by talking about that by introducing an example of addition. So think about this for a second. Think about 2 plus 2 plus 2 plus 2. Okay, I'm adding 2 together 5 times. You can quickly do the math in your head. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. The answer to this would be 10. There's another way that we could write this. There's another way that we could write this expression, 2 plus 2 plus 2 plus 2 plus 2, much simpler. And you might already be saying what that is in your head. That would be 5 times 2. This little dot is another notation for multiplication. And this is a multiplication problem. And as you can see, 5 times 2, that is the same as 10. And really, all that multiplication is, this expression right here, 5 times 2, all that is repeated addition. These are mathematically equivalent. They are the exact same thing. These two expressions are two different ways of saying the exact same thing. So all multiplication is, I want you to write this down. I want you to write multiplication, and then underneath it, I want you to write repeated addition. Okay? So I'm just going to write multiplication. I want you to write underneath that repeated addition. That why multiplication actually exists is it's just the repeated act of adding. 5 times 2 is the same as adding 2 together 5 times. Well, let's look at a different example. What if instead of adding these 5 2's, we're multiplying? Once again, you can do this math in your head. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the answer to this would be 32. Well, we actually have a simpler way of writing this as well. We don't have to write this all the way out to understand what we mean. We can just write 2 raised to the 5th power. And those two are mathematically equivalent. 2 to the 5th is the same as 2 times 2 times 2 times 2 times 2. 2 to the 5th, 2 raised to the power of 5 is the same as multiplying 2 5 times. That's exactly what an exponent is. It's telling you what number to multiply, in this case 2, and how many times to multiply it, 5. We have names for these two different numbers. This is called the base, and this right here is called the power, or the exponent. And this is something that you should be familiar with, but I don't know if it's ever been explained to you in this way, where this is the number that we're multiplying, this 2. The base is what number we're multiplying, and the power is just how many times we're multiplying it. And that's where exponents come from. All it is a notation for repeated multiplication. And I want you to write that down as well, that exponents are just repeated multiplication. Okay? Exponents are repeated multiplication. So multiplication is just repeated addition, and exponents is just repeated multiplication. So that's where exponents actually come from. It's a notation for us to be able to write lots of multiplication really simply. So how does that affect us solving problems? Well, let's look at this problem really quickly. What is 2 to the 5th times 2 to the 6th? Well, let's pretend that we don't know our exponent rules. How would you solve this? Well, for most of us, at least for me, before I knew my exponent rules, I would have just written it out. 2 to the 5th, that's the multiplication of 2 5 times. And then we're multiplying all of this, and I'm going to put a little box around that. We're going to multiply that by the multiplication of 2 6 times. Okay, so we have this little box over here of 2 to the 5th, and we have this little box over here of 2 to the 6th, and we're multiplying them together. And when we write it all out, it looks like this. Well, let's count how many 2's we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 to the 5th times 2 to the 6th, when we write it all out, is the same as multiplying 2 11 times. And when you actually do that math, that comes out to 2,048. Okay? So when you think about it, there's a rule that comes out of this. And of course, you know this as the product rule. And the product rule just states this, that when I'm multiplying two numbers that have the same base, here you see they're both 2's, then when I want to know what the answer would be, what the final product would be when I'm multiplying two numbers with the same base but different exponents, all I do is I add the exponents. That's where this rule comes from. 11 comes from the addition of 5 and 6. Another way to write this would be 2 to the 5th times 2 to the 6th is the same as 2 raised to the power of 5 plus 6, which is 2 to the 11th. And you can just remember this rule, that when you're doing this, you just add the exponents together to get this, instead of having to write it out to count how many times you're multiplying 2 together. But there's an important stipulation to this product rule, and that stipulation is that the bases have to be the same. In order for the power rule to work, then the bases both have to be 2's. In this case, if this number was a 3 instead, it wouldn't work. We couldn't use the product rule. So what about when we're dividing numbers with exponents? How does that change? Well, once again, if you didn't know exponent rules, if you were unfamiliar with the quotient rule, how would you solve this? I want you to think about that for a second. For most of us, once again, like when we were younger, we probably would have just written it out. That I'm going to multiply 3. 3 to the 12th means I'm multiplying 3 12 times. So I would write that out 12 times. See how many I'm at. 3 more, 10, 11, and 12. So I have the multiplication of 12 3's divided by the multiplication of 9 3's, 2. Okay, and if we were going to do this, how I would have done it when I was younger is I would have said, okay, every time there's a 3 on top, I know that I can cross one, and there's a 3 on the bottom, I know that I can cross one out. So let's go through. There's 1, 2, 3, 4, 6, 7, 8, and 9. And what we're left with right here is we are left with another fraction. We still have 3 3's on top and nothing on the bottom, but it's not actually nothing. When we cross all of these out, what's 3 divided by 3? Well, that's just 1. So there's a 1 on the bottom. What this comes out to is 27. 3 times 3 is 9 times 3 is 27. But there's a rule that comes out of this. What do I mean? Well, this is the quotient rule, and this is something you're familiar with. I'll write that out for you. So quotient rule. And what the quotient rule says is when I'm dividing two numbers, 3 to the 12th and 3 to the 9th, that have the same base, what we do is we subtract the exponents. So that 3 to the 12th over the 3 to the 9th is the same as 3 to the 12th minus 9. 3 to the 12th minus 9, which is 3 to the 3rd 12 minus 9 is 3. And 3 to the third is the same as 3 times 3 times 3, which is 27. And that's where the quotient rule comes from. If you had actually taken the time to write this all the way out and done the math, you would have gotten 27 just the same way as if you would have just jumped straight to using the quotient rule. And so that's where the product rule and the quotient rule come from. It allows us to, instead of having to do this every time we see the multiplication of two numbers with exponents, we can just use these rules really quickly to get to what our answer is going to be. So that's how the product rule and the quotient rule actually make our life a lot simpler. We're going to do one more example really quickly. What about 3 to the 6 over 3 to the 8th? Well, we're dividing two numbers that have the same base to different exponents. So 3 to the 6 over 3 to the 8th would be the same as 3 to the 6 minus 8. We always start with the number on top. 6 minus 8 is -2, so that's the same as 3 to the -2. And we have a number raised to a negative exponent. Well, what do we do with negative exponents? That's the same as writing this number, where we write it in the denominator of a fraction, but now the exponent is positive. So that would be 1 over 3 squared. And 1 over 3 squared is 1 over 9. So the quotient rule still works even when we have numbers with negative exponents. It doesn't matter. You can do this quotient rule all of the time. Something I want you to do, I want you to try this next problem. I'm going to write it down in your notes, and I want you to just think about it. Think about this problem. X to the third times x to the -2nd power. I want you to work on this. I want you to maybe come up with an answer. But more importantly, what I want you to do is not just come up with an answer. Think about why, whatever answer you get, why is that the answer? I want you to be able to answer that question. In class, we're going to talk about this, and I want you to think about that. What do you get, and then why is that the answer? And then the next thing I want you to do, and this is how we're going to finish this lesson, is I want you to think about this question. What is different between these two expressions? There's lots of ways you could answer this problem. You could answer it as a written argument. You could actually do the math. You could show the mathematical difference. You could argue why they look different. But I want you to just think about this. I want you to write down an answer. I want you to come up with a full answer. And I'm going to grade your answer tomorrow in class. This is your homework. So I want you to think about this, write it down, figure out why. Think about why. Don't just say what it is, but also say why they are different. And then we're going to talk about it first thing in class tomorrow.